All right, good afternoon. CSE 102. Computer programming today is the April 12th, 2023. So today we're going to talk about abstract classes. Don't think we'll get to interfaces today, but it's part of the same lecture set. But this is connected to what we talked about a couple weeks ago about inheritance in terms of how classes inherit from each other. This is where what if, well, we'll get into it. Okay, but basically the idea is what if we have a parent class, but we don't want anything. So you got a question about the assignment. Let's see. We can pull that up. Yes, they do actually. So this actually, someone asked this question and I actually answered it. So let me go ahead and answer it here. Okay, which is every exception should take a parameter for its constructor. So if we look here, all right, all constructors should take parameters in the order given, right, and initialize any empty collections if they exist. Okay, so all constructors should take parameters in the order given, which means that, and thank you for asking this question because I realized that this was something I wanted to bring up in here. So the customer not found exception has an attribute, a string attribute of phone, which means its constructor should take a string parameter. The insufficient funds exception has parameters total and payment. So it should take, the constructor should take two double parameters in that order, total and then payment. Okay. The others, like invalid amount exception and product not found exception, they have constructors that are explicitly defined because they don't just take both parameters. There's one that takes only the amount parameter. There's one that takes both amount and quantity. Okay, so there's an additional constructor defined for invalid amount exception, right? But for all the others, those fall under this instruction right here. Okay. All right, so I hope that clears up any questions or concerns you guys might have had, right? So that's how you should take care of that. All right, any question there? Get product string name. You're talking about this one here? Well, let's take a look at the examples. Let's see. What does the example show? Here I have a capital S, but here I found it with a lowercase s. All right, so that should answer that question. All right, any question? Any other questions? Good. Thank you for asking those questions. If you don't know, make sure you ask questions. Great. No, you should be able to do it with any of the collection types that we already have talked about. Right. You don't have to use Java util collections. In fact, we haven't talked about it in this course yet, so I don't expect you to use it. All right. All right. So good questions. All right. So let's talk about abstract, because this is where we're going to go with assignment 3 when we get there. Also expect that this will be on the midterm, because midterm week is scheduled for the week that I had put as the tentative midterm week, but I still don't know anything about next week for Ramazan Bayram, if we are having any time off for that for this course. So we'll see. All right. Being abstract, Edgar Dijkstra, who you will learn about when you talk about algorithms class. He has a graph algorithm that's fairly well known. All right, but being abstract is something profoundly different, rather, from being vague. We're not just trying to be vague. We're not trying to be ambiguous, right? We're trying to say specifically, in the case of abstraction for Java, abstract classes, is we're trying to say, what if we have a general class, but we don't want to create an object of that class, right? We want to define some things for classes of that type that they all share, they all have in common, like shapes all have certain things in common, right? But we want the concrete things, the actual object things, to be something specific, like a circle or a square or a rectangle, right? So the purpose of abstraction, of creating abstract classes in this case, not to be vague, but to create something in which one can be precise. All right, so we're actually trying to force our programmers to be able to have to create something specific. Okay, so all right, so if we look back at our geometric object example from before, all right, where we have certain things that all geometric objects have in common, okay, such as get area, they all have an area. Now, for this, we're talking about two-dimensional geometric objects, right? But get area, get perimeter. Well, what is a geometric object on its own? Can we create a thing that is a geometric object? Well, no. I mean, it's got to be something like a circle or a rectangle or a square or a triangle or an octagon or whatever. But all of those things are very specific, right? This general idea of a geometric object, we don't really have a definition for what that is. We have a definition for a circle. We have a definition for a rectangle. So these are the things that we will refer to as non-abstract or concrete. So we have a concrete class like circle. We have a concrete class like rectangle. But those things inherit from their parent certain things that all geometric objects have in common. Right. So notice that in this case, the abstract class name is italicized. When we italicize a class name, we are telling, in this case, the UML class diagram, we are saying this class is abstract. We will not be able to create an object of this type. Okay. We will have to create its children instead. Okay. All right. We can have abstract methods. Oh, let me point that out. Abstract methods are also italicized. Now, the reason for why we would have an abstract method is we're saying this is a method that every child is going to have. Every type of geometric object has an area. Every type of geometric object has a perimeter. But how those things are defined, how do we define the area of a circle? It's different from how we define the area of a rectangle, which is different from how we define the area of another object, of another type of object, right? Same thing with the perimeter, or in the case of the circle, we would call that the circumference, right? But for the perimeter, those definitions are different from concrete object type to concrete object type, right? Circle is different from rectangle, is different from triangle, right? And so an abstract method is where we're saying every child has to have this method defined, but I don't want to define it in the parent class. I want to make sure all of the children have it, but I don't want to define it in the parent class. These concrete methods up here in the abstract class, they're all defined in the parent class. All right. But these abstract methods, it's like, if you have any C programming experience, it's like a method header, right? Where we're saying we want to, or sorry, not a method header, a function header, where we're saying we want to have this exist. We just don't want to define it here. We want to define it down here. Okay. So you might say, well, why even have that up here at all? Why not just have it defined down here and be done with it? Well, for a few reasons. One, when we define an abstract method here in the parent abstract class, when we go to create our child class, the compiler will fuss at us if we don't define the abstract method. So all the methods up here have to be given something here. If this just didn't exist here, if we just said, you know what, I'm not going to even create the abstract method here. I'm just not going to put it here. It's done. All right, it's gone. Then there's nothing requiring me to give a getArea method for the circle class. All right, the compiler doesn't require it. It would just be basically my own word that I'm going to do it, but nothing would require it of me. By having this abstract method here, when I go to create my circle class and I say it extends the geometric object class, the compiler will require me to define any abstract methods. Also, another thing that it will allow for is, so you guys remember that we can have a variable type what'd you call it? O, right? A variable type of the parent class. This is still true. We can still create a geometric object variable that is some other object below, right? Some other child object. Okay, so we could create a geometric object variable that points to a circle object. Now, when we used O.getArea, I'll just shorthand it here, getArea, right? When we say O.getArea, there's no compiler issue. We don't have to cast this. We don't have to explicitly cast this to a circle object to use its getArea method, because the compiler knows that geometric object O, the geometric object, has a getArea method. Okay, we'll see that in some examples in just a moment.
Teacher.
Okay. Yep. Question.
Can you redefine abstract method and abstract class from normal method and normal classes?
Well, my volume must be really low. Can we redefine an abstract class to be what now?
Can you redefine abstract method and abstract class? Because I didn't get the difference between normal method and normal class.
Okay, so we haven't gotten to the code yet. So basically the way you tell the compiler that a specific class is abstract is just using the abstract keyword. Same thing with the abstract method or variable.
Did you talk about the difference? Because you said something like we can define geometrical objects, but we can't define abstract things.
Right. So, so let me show you. So, let's go back up. So here, the geometric object is the abstract class, which means we cannot use the new keyword with that class. We cannot do this, okay? We cannot say new geometric object with whatever, right? This is not going to, the compiler will fuss at us for this because we cannot create an object of that type. But we can create a reference variable of that type. The object itself has to be one of the children, but the variable can be a parent.
Oh, so it's like a general parent class? Is it something like
Yeah,
that?
right. So it's general, right? It's saying there are certain things that all geometric objects have in common.
Mm-hmm.
We don't want to say though that anything can just be a general geometric object. So it would be like saying I have a car, right? Well, but my car is a specific type of car, right? It could be a van, it could be a sedan, it could be a sports car. That would be really nice if I had one of those. But it's different types of cars, right? But it's really even more than that. It's a specific brand and make of car, right? It's a particular specific vehicle, right?
Mm-hmm.
So if you were to say all cars have certain things in common and we want to define those, but when it comes to actually creating the car itself, it's going to have to be something like, a 2023 Ferrari something. Like I make up Ferrari because I know that's a famous car and I'll never drive one, right? Or it has to be, some of you guys know I have a Star X. It's a 2004 Hyundai Star X, and that's a specific car, and that's what it has. That's the concrete thing.
All right, I get it. Thank you.
Sure. Okay. So if we're moving on, so an abstract method cannot be contained in a non-abstract class or concrete. The other word we'll use for non-abstract is concrete class, right? So if a subclass of an abstract superclass does not override all the abstract methods, the subclass must be defined abstract. So in other words, remember, children classes, subclasses inherit all of its parents' methods. So circle gets get area. It also gets get perimeter. Because these are abstract, if I don't define them here, then the compiler will yell at me. The compiler will give me a compiler error. Not all the parent methods, there's an abstract method that exists here. Now, there is a way around that. I could say that circle itself is abstract, and then I don't have to define all of the geometric object methods. But then eventually I'm going to have to get down to a child class that is concrete. And by making that child class concrete, all of the parent abstract methods have to be implemented. Okay. All right. So, right. This is something I mentioned a second ago. We cannot create an object from an abstract class. We can have a reference variable, right? But we cannot create an object using the new keyword. So we can still define constructors. So even though we can't create a new object of that type, we can still have a constructor that does certain things when an object of its type is created. So when a child object is created. All right. And then that child object would call its constructor using the super keyword. We talked about that when we talked about inheritance a couple of weeks ago. All right. Okay. Abstract classes don't have to have any abstract methods. There's no requirement that an abstract class has an abstract method. Right. Right. So we can define an abstract class that contains no abstract methods. It's fine. But we still cannot create instances of that class with the new operator. We can't because the class itself is abstract. Okay. But if a class contains abstract methods, the class itself must be abstract as well. Okay. That also comes back to the thing 2 slides ago, where if a child class doesn't implement how the abstract methods of the parent, then it itself must be abstract as well. Okay. A child class can be abstract even if a superclass, its parent class, is concrete, is non-abstract. For example, the object class is concrete. We create objects that are of the object class type. We've done that before in previous examples. The object class is concrete, but all of its, sorry, not all, but any class that's defined as abstract, like geometric object, has object as its parent. Okay. In fact, okay, we'll use C for concrete, and we'll use A for abstract. Okay. All right. So here what we've learned is that a concrete parent class can have an abstract child. The object class has geometric object as its child. Okay. What about, can a concrete class have a concrete parent? Yep. All of our classes that we've created so far have been concrete. We haven't created any classes that are abstract yet, and they all had object as its parent, or somehow up there. So yes. Okay. Can an abstract class have an abstract child? Yeah, in fact, one of the things we just said was that an abstract class, that if its abstract methods are not implemented by the child itself must be abstract. That's one of the previous slides just said that. So, yeah, an abstract class can have an abstract child if, in fact, in some cases, we're required to make the child abstract. Okay. Now, finally, can an abstract class have a concrete child? Yeah. Yep. An abstract class can have a concrete child, and in fact, if an abstract class has no concrete children, there's really kind of no point in that abstract class existing, right? Because it means we can't create any objects of that type, right? All right, so clearly all four of these relationships are possible. Okay. By the way, that makes for a really good true-false question on an exam or a quiz, just so you know. Okay. Not saying anything, I'm just saying maybe. All right. Okay, a concrete method can be overridden to be abstract. So if a subclass is abstract, right, it can override a parent's concrete method to be can override its parent method to be abstract. Right. Again, the subclass must be defined as abstract in that situation. Okay. Again, we cannot create an instance, an object from an abstract class using the new operator, but we can create a reference variable. We can also create an array of those things. So geometric object is abstract, but we can create an array of geometric objects and create basically a new array of geometric objects. This does not create the object itself. Remember, this creates an array, a set of data locations that all point to objects of type geometric objects. So let me show you what I mean by that. If we were to say, give me a geometric object, let's call it G, equals new circle, for example. Okay. What happens is we have a memory location for G, and what G can point to is anything that is a geometric object or a child of geometric object. So it creates a circle, right? And this points to it. Okay. Now, can I create then a rectangle and change it and say G equals new rectangle? Can I do that? Can I then take this and instead of pointing to circle, now it points to this rectangle? Can I do that? You guys are not sure? You're like, oh no, that seems weird. Maybe, yeah, maybe. I like the question mark there. It's like, yes, right? Yeah, you can, because this thing, the only requirement on this memory location is it's saying the thing that it points to is something of type geometric object or one of its children. Well, it can't point to a geometric object itself because it's abstract, so we couldn't create an object of that type. But circle, rectangle are both children. So yeah, I can point to that. That's fine, right? Okay, so what an array does is it's saying, okay, I'm going to create, in this case, 10, 2, 3, 4, 5, 6, 7, 8, 1, 2, 3, 4, 5, 6, 7, 8, no, 10. Okay, so I'm creating 10 memory locations, and each one of them must point to something that's a geometric object or a child of it. And again, geometric object itself is abstract, so I can't create any objects of that type, but I can create circles and rectangles. The nice thing is, each one of these doesn't have to point to all the same thing. So it's not like I didn't just create 10 circles. I didn't just create 10 rectangles. I can create a mixture of them. So some could be circles. This could point to a circle. This could point to a rectangle. This could point to a circle. This could point to a circle. This could point to a rectangle, so forth. It could mix them all up, and that's okay. All right. So they don't all have to point to the same type. That's kind of cool, right? That we can mix it all up. Right. So it's kind of like coming back to an example we talked about before with inheritance. We talked about fruit, and fruit, the parent class could have apples and oranges and pineapples and strawberries and all kinds of fruit, right? And the nice thing is I can have a cart that would have a bunch of different types of fruit in it. It can have apples in it and oranges and bananas and all kinds of fruit, right? And star fruit, if you've ever heard of star fruit. Yeah. So if I go to the bazaar, I'm not like my cart can contain lots of different things. Okay. Or just like in your program, your store program that you guys are writing, your product collection can contain all kinds of products. Contain food products, can contain cleaning products, right? It can contain product itself right now. But what if in the future we decide that product itself should be abstract, and all of the products that we order have to be of a specific, have to be of a type, have to be either a cleaning product or a food product or a technology product or something else that we define, right? Where the general thing product, there's certain things that all products have in common. All products have a price. All products have a name, right? But it's the subclasses that actually tell us what the product is and are actually the concrete things that we are buying, right? Okay. So we would want to be able to keep something like this where we have an array or an array list of products that we don't have to maintain one array for all the food products and one array for all the cleaning products and one array for all the technology products. What we would like to be able to have is one array that is all of our products that our customer is ordering and keep it all together, all in one nice place, right? And that's what we can do with something like this, where we can still, even though geometric object is abstract, we can still create an array of that type, even though we cannot create an individual object of that type. Because really what we're creating is not an array of geometric objects, we're creating an array of reference memory locations, an array of reference variables where each reference variable points to something of that type, okay, of a child of that type. All right. So for example, in Java, there's a thing called the number class, the abstract number class, that all of its children are different types of numbers. So remember we talked about wrapper classes for things like int, the integer wrapper class for the primitive data type int, double with a capital D, the wrapper class for the primitive data type double. Right, we talked about that before. Every single one of these is a child of the abstract number class, where the number class has specific methods, right? That one, it defines the byte value and the short value, but it also has other methods like int value, long value, float value, double value, right, that it uses. But these methods are abstract, which means each one of these defines it differently. So the integer class defines the double value method differently from how the double or the float or the long define it. All right. I'm going to skip over the next one because the calendar stuff isn't necessarily important. All right. What time is it? 4:10. I don't really want to get into interfaces today, so let's do this. Let's break early. Okay, so it's 4:10, 4:08. We'll come, if there's no questions specifically, especially any questions that might be answered by an example, because what I'm going to do is I'm going to, in the second hour, we'll just do a few examples. Okay, we'll go interfaces tomorrow. All right, and then we'll do some examples of abstract classes today in the second time. All right, so we'll come back at 4:20, and we will pick up and do some examples using abstract classes. All right, see you guys in 10 minutes.